Welcome back, everybody. We are continuing with our 3.5 notes. Today we're going to talk about slope-intercept form and constant functions. So what is slope-intercept form? Slope-intercept form is y equals mx plus b, where m is slope, b is your y-intercept. And then x and y stay in the equation as the ordered pairs that you would get for your graph. A constant function is a linear function in the form y equals 0x plus b, or y equals b, which is actually a horizontal line. So an example of slope-intercept form would be y equals 3 halves x minus 7, or f of x is equal to negative 8 minus 3/7 x. Either of those are slope-intercept form. Whatever is attached with the x is the slope. Whatever's not attached with x is the y-intercept. A constant function, or the horizontal line examples, would be y equals 9, y equals negative 7.2, y equals 1/3. So those are all examples of what that would be. Here you can see another representation for slope-intercept form. Let's try a couple. Find the slope and the y-intercept of the graph of each linear equation. So all we're doing is finding the slope and the y-intercept. So in number 12, here's where x is. So the number in front of x is our slope. That makes our slope 3, or 3/1. You can write it either way, depends on if you want it to be in rise over run form or just as a slope number. And then plus 4 is our b, or our y-intercept. For number 13, notice that there is no x here. So y is equal to 0x plus, it's plus because this is positive, 6.5. That means our slope is 0 slope, and our y-intercept is 6.5. Remember, 13 is a horizontal line. So it would go like this at 6.5. For number 14, this is not in slope-intercept form, so I can't just look at it and say, oh, here's the slope and here's the y-intercept. I can't do that until y is alone. So to get y alone, we start with moving the negative 5x. So the opposite of a negative is a positive. So we're adding 5x to the other side. Now remember, I can't add the negative 2 and the 5x together to get a 3 because they are not like terms. I still have this negative y. Remember, that's negative 1 times y. The opposite of negative 1 times y is dividing every single thing by negative 1. So a negative over a negative gives us a positive y. A negative over a negative gives us a positive 2. And a positive over a negative gives us a negative 5x. Now that this is in slope-intercept form, I can say, okay, well, -5 is what's touching the x. And I can put that over 1 for rise over run form. But our slope is -5 or -5 over 1. You can write either one, totally fine with either. And then our y-intercept, or b, is +2. It's positive because there's no negative in front there. So +2 is our y-intercept. Number 15 is very special. And that's because this is another special line. X equals -4 is a vertical line. So I'm going to graph that just for a visual while we're talking about the slope and the y-intercept. So -4 is here, 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 and here. So here's my vertical line for x is equal to -4. So we talked about in the last set of notes for 3.5 that a vertical line has undefined or no slope, right? Undefined or no slope. What we did not talk about was the y-intercept. So our slope is undefined or no slope, but what about the y-intercept? Does this line look like it's ever going to cross, if I drew it exactly straight, is that ever going to cross the y-axis? Is it ever going to go over there? And the answer to that is no. So there is no y-intercept either. So because 15 is a vertical line, it is undefined or no slope, and has no y-intercept, it will never, ever, ever curve and cross over that y-axis. All right, this is where we're going to stop today. Please give the U-Try 16 through 19 a shot. Talk about it in next class. Thanks very much for joining me. Have a great evening.